Assalamualaikum. So we are from Group 6 and we are going to present our project, which is car parking system. So this is the Group 6 team member, which is me, Farah Rafika, Muhammad Faisal, and Nur Hamidah Sotia. So I'll pass this presentation to Farah Rafika first.
Okay, for introduction, car parking system has been around almost since the time car were invented. In any area where there is significant amount of traffic, there are car parking system. Next, some of the benefit of automatic intelligent car parking system are it can accommodate maximum numbers of cars in minimum spaces, customized parking solution, low maintenance and operation cost, safety for both car and the driver, faster parking and retrieval and eco-friendliness. Lastly, this system reduces the time in parking and can count the total number of cars available in the parking and total spot available in the parking for car. Next. So for project objective, we have 3, which is time saving. No need to waste time to find the available parking slot. Second, detect slot availability. Instantly detect how many car parking slots still available. And lastly, detect number of cars. Instantly detect how many cars already in the parking garage. So next, I will pass to Hamida Sofia.
So for the system layout, the PLC car parking system consists of 2 garages for cars to park. In this system, each garage occupies the maximum number of 5 cars at a time. Every time the cars enter and exit the garage, the system will count the number of the sum of the number of the car in the garage. If limit exceeds the gate for the gate 1, the gate is filled signal will turn on notifying the driver not to enter the gate 1 and need to proceed to the gate 2 because there is no space available in garage 1. When the first garage is full, the gate for the second garage will open, allowing the car to enter the second garage. If limit exceeds in second garage, the no parking signal will turn on, notifying the drivers that there are no parking available. Both gate 1 and gate 2 will be turned off. Only the exit gate 1, only the exit gate 2 and exit gate 1 is turned on, allowing the cars to go out from the garage. So next is the flow chart, which will show the flow of the system. And then next is IO mapping, also showing the system overall. Next, I will pass to Alia for the diagram.
So this is the ladder diagram, which shows from round 0 to round 1. So for the round 0, this rung is the latching rung, which is designed to operate the system through the master start and the stop. So the first rung is for the gate 1 entry sensor to detect the entrance of cars into the garage. The second rung is the gate 1 exit sensor to detect the exit of cars out of the garage. The third rung is to count the number of cars entry and exit that limit until 5 number of cars only in the garage 1, which uses the counter. So next is the fourth rung, which is to compare the number of the cars with number of limit, which is 5 for garage 1. When the limit exceeds, the gate 1 is filled signal will be turned on. And fifth rung is for the gate 2 entry sensor to detect the entrance of cars into the garage. And run 6 is for the gate 2 exit sensor to detect the exit of cars out of the garage. And then it's the rung 7, which is to count the number of cars entry and exit that limit until 5 number of cars to enter into the garage 2 using the counter. And the last rung is to compare the number of the cars with number of limit, which is 5 number of cars for the second garage. And when the limit exceeds, the no parking signal will be turned on. So in the nutshell, this project has achieved the project objective, which is time saving, detect slot availability, and number of cars in the garage. So this PLC car parking system can detect the slot availability for the parking using the comparator in the PLC system design. Furthermore, this PLC car parking also can detect the number of cars based on counter that used in the ladder diagram provided. So this project has 6 input and 5 output, which is used in this whole system. 4 from the input is the sensor at the gates, and 1 is a push button for starting the whole system, and the other one is for the stop push button. So the 5 output is divided by 2 parts, which is 3 output for the open and close gate at each level of gates, and the other 2 is to detect the availability for the cars. So this whole project is basically convenient for all type of parking system. So before I end this presentation, I would like to show the simulation for our ladder diagram. Give me a minute. Alright, can you see my screen?
Yes.
Okay, so this our ladder diagram. So this is the first rung. So first we start the whole system. Okay, so the whole system is activated. So this is the gate 1 entry sensor where it detects the cars. So for example, when there's one car enters, so the counter will read it as 1. So when the car exits here, so this is the gate 1 exit sensor, the counter will go back to 0. So let's say when the cars enter until 5 cars, there's already 5 cars. So when there's 5 cars, it will turn on the gate 1. It will turn on the second garage. So it will allow the cars to enter the second garage. So when the first gate is not turned on, it won't allow the cars to enter the second garage. So let me show you what if. So this is okay. So this is what happens when there's a car exit. The first garage has 4 cars. So this shows that the Second garage is not activated, so there's no cars allowed to enter the garage. Okay. So it will, and the second garage is also filled. The display that shows the gate 2 is filled will be turned on. So that is basically our ladder diagram for this project. So that's all from us. Okay, thank you for watching and have a good day.
Thank you all.